Trigonometry is what we're getting ready to study. And there are three ratios of the side lengths of triangles, right triangles, that we are going to start off talking about. All right triangles that have the exact same angles will have the same proportions between their sides. So here I'm showing you a right triangle, three right triangles, and they each have a 30-degree angle. You can see that the side opposite 30 degrees is 2. Here, the side opposite 30 degrees is 60, and here, the side opposite 30 degrees is 120. The hypotenuse on this first triangle, which is always the side that is across from the right angle, is 4. Hypotenuse on this triangle is 120. The hypotenuse on this triangle is 240. So you can see that no matter what size the right triangle is, if it has a 30-degree angle as its smaller angle, then the ratio between the side that is opposite to the 30-degree angle and the hypotenuse is always 1/2. So 2/4, 60 over 120, 120 over 240. So that ratio for a 30-degree angle, that's always 1/2. If you punch 30 degrees into your calculator and you hit the sine key, you will always get 1/2 because it doesn't matter how big or small the triangle is, that ratio between the opposite side to 30 and the hypotenuse of that triangle will always be 1/2. And that value is inside your calculator. Whenever you hit 30 degrees and hit sine, S-I-N, you will always get the same value. It will be 1/2. Suppose I'm flying a kite and I know that I have 200 feet of string and I've let all the string out and I measure the angle from the ground to the kite string and I find out that's 30 degrees, then I would know the height of my kite is 100 because I know that the sine of 30 degrees is equal to 1/2. And I know that the sine is opposite, which in this picture is x, over hypotenuse, which in this picture is 200. And so if I take the cross product here, I'm going to have 200 is equal to 2x, and so x is 100 feet. So this is the kind of thing, although there are many, many, many things that you use trigonometry for, but this gives you an idea, a very simple idea of one of the things you could use it for that you couldn't really do without trigonometry. Let's get down to the basics of the three trigonometric functions you are going to learn, which it sounds like you already learned in Algebra 1. We're just going to review it, but some people probably haven't learned it yet. So if we have a right triangle like this one right here, and we call one of the angles theta, angles are usually named with theta or phi, or there are a couple other Greek letters that are used for angles. So make sure that you know what this symbol represents. It represents a Greek letter called theta, and it is used to talk about angles of triangles. So we want to learn these three functions, which are ratios of side lengths from the perspective of whatever angle you're looking at. Okay, so if I look for the sine of theta, okay, that means, look at theta right here. I want to see the side that is opposite to theta. That means across from theta. That goes in the numerator. I want to talk about the hypotenuse. The hypotenuse of a right triangle is always right across from the right angle. So that is what the sine function means. It means look at this angle, theta. Tell me the ratio of the side opposite to theta, that length, and divide that by the hypotenuse of that same triangle. That's what sine is. Now, I would never write the word sine with no angle because it doesn't mean anything. If there isn't an angle next to this word, it just means sin, which is missing the mark, going against God's way, doing what you know is wrong, not doing what you know is right. That's sin, okay? And that can be written by itself. But trigonometric function, sine, is never going to just be sitting there by itself. It has to have an angle next to it. We have to talk about these ratios in relation to one of the angles in the triangle. Okay, so sine is opposite over hypotenuse. The cosine of theta, this is the ratio of the length of the adjacent side to theta, which is the one that touches theta, divided by the hypotenuse, the longest side. The tangent of theta is another ratio. It is the opposite side to theta divided by the adjacent side. Sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. Tangent theta is opposite over adjacent. Okay, so we're going to look at this problem and we're just going to practice remembering what those trig functions are, what the ratios are. So find the sine of A. All right, we're looking at the first triangle. Here's the angle A. We want to take the sine of A. Remember, sine is opposite over hypotenuse. What does that mean? That means if you're looking at angle A, what side is opposite? It's this one. So that is 4. And then the hypotenuse of a right triangle is always across from the right angle, and that is 7. So this is the sine of A. Now, in this problem, we were given a picture. We're just practicing what these ratios are. Your book just rounds that to 2 decimal places. All right, now in this triangle here, we're going to find the cosine of B. So cosine of B, adjacent over hypotenuse. In this triangle, if you're looking at angle B, the side adjacent to angle B is 7. So that goes in the numerator. And the side that is the hypotenuse of the triangle is still the side that's across from the right angle, which is 8.6. If you punch that into your calculator, you will get about 0.81. That's just an approximation. All right. If you are looking for the tangent of C here, tangent of C is equal to opposite over adjacent side. So what is that? If you're looking at C, the opposite side is 6. The adjacent side is 8. And so that is 3/4, which you know is 0.75. Okay, so that's just practicing what the ratios are. Say you have a situation where it says find the angle whose sine is 0.643. Okay, so now you don't know the angle that we're talking about. And so what you would do is you would set up this equation. You would say sine of A, let's call it the angle we don't know, is 0.643. Now you've got to figure out what A is. Can you divide both sides by sine? No, you cannot. This is not multiplication. This is not sine times A. This is the sine of A. So the only way you're going to figure out what A is to use the inverse sine function. And if you look on your calculator, that is sine with a little -1 raised up next to it. That would be the inverse function of sine. That is the function you use when you know the ratio, 0.643, but you don't know the angle. So what you would do on your calculator is you would punch in 0.643, and then you would hit the button that says sine, but it's got an inverse. And when you do that, that is going to tell you what the angle is. Now, some of your calculators, you would hit the inverse sine button first, and then you'd hit 0.643, and then you'd hit equals. So it just depends on how your calculator works, and you need to make sure you know that. So if I punch in 0.643, and I hit inverse, or second function, sine, that is going to give me about 40 degrees. So A is about 40 degrees. So if I want to find the angle whose cosine is 0.216, what I'm asking is, okay, cosine of some angle, I don't know, I'll call it B, is 0.216. If I want to figure out what B is, I have to take the inverse cosine of 0.216. So cosine inverse of 0.216. And to do that, you punch it into your calculator, whichever way you're supposed to, whether you're supposed to hit inverse cosine first or 0.216 first, make sure you know. 0.216, and then you're going to hit second function, cosine. And that will tell you that it's about 77.5 degrees. So B is about 77.5 degrees. Okay, so you need to understand that these values, cosine, sine, tangent, these are not things you can figure out by multiplying or dividing or isolating. They are only available to you in your calculator. Some of them you will get to know and you'll remember, like sine 30 is 1/2. We learned that at the beginning. But these are not values you can figure out. They are values that are in your calculator. So don't try to somehow isolate B in that equation by using algebra. That's not going to work. This is different. It's trigonometry.